So hello everybody, today we have this type of decorative lights in my workshop. As you can see on your screen, the driver is burnt. Here you can see the driver here. You can see it's MB10M. Here you can see it's MB10M. So today we replace this decorative lights driver circuit with my this SMD rework station. So let's switch it on. So first of all, we use our hot air station for these replacements and just put the heat on it and just trying to desolder it out and put the new IC or bridge rectifier and replace it with the new one. Here you can see we just set the temperature on 300 degrees Celsius. You can see we just remove this wire here. So here you can see the MB10M. Here is the IC or bridge rectifier that we have used. So here we have the strip of the new bridge rectifiers. It's MB10M that is replaced with this MB10F. Here you can see it's the SMD component, it's a dip, it's dual inline. So we just bend the edges and connect like this way. Here you can see the white strip is for output line. Here we connect like this and solder it out and see it works or not. Now this is time for soldering. Here you can see the arrangements like that. We just connect I just connect my oscilloscope with this rectifier and then we just switch on the circuit here. You can see the power goes here and this turns here. I just put my oscilloscope probe with this lit up decorative light and just see my oscilloscopes You can see the measurements on my screen. So as I press the auto button here you can see the AC to DC. It's a DC signal here, and I press the measure button here, the all parameters. Here you can see the different parameters here that this wave produced. So with this we just get all the parameters. We set it down the trigger minutes coupling. We just select the DC. Here we have so these are all the parameters. We just analyze the wave from here. It's 2 volts per division. You can see the circuit is running here. From here we just check the glitches in the DC signal, and here we have the voltage levels. I just set the probes to times 10. Here you can see it's times 10 button on, so every voltage is divided by 10. So if we have 100 volts it shows 10 volts and 10. So here you can see. I hope you enjoy my works. Thanks for watching. This is Ramit Diman from Ramit Engineering Works. Here you can see. So if we shut it down, the off button, I just put my finger on this, and here I can see there's no temperature increase. It's cold as normal. So this is very good symbol for the life of this light.